Have you ever looked up at the sky on a sunny day and wondered why it's blue instead of green, red, or purple? It's one of those questions that seems simple but has a really cool scientific answer. Today we're going to discover the amazing reason behind our beautiful blue sky. By the end of this video, you'll be able to explain this mystery to your friends and family. Let's dive into this colorful adventure together. You might think sunlight is just white or yellow, but it's actually made up of all the colors of the rainbow mixed together. When you see a rainbow after it rains, you're actually seeing all these hidden colors that were inside the white sunlight all along. Think of white light like a big box of crayons. It looks like one thing, but inside there are red, orange, yellow, green, blue, indigo, and violet, all squished together. Scientists discovered this hundreds of years ago, and it's the first clue to solving our blue sky mystery. Just like waves in the ocean, light travels in waves too, but these waves are incredibly tiny, way too small for us to see. Each color has its own special wave size, kind of like how different musical notes have different pitches. Blue light has really short, quick waves that bounce around a lot, while red light has longer, lazier waves that don't bounce as much. This difference in wave sizes is super important for understanding why we see blue in the sky. Imagine blue light waves as excited puppies jumping around, while red light waves are like calm cats walking slowly. Our planet Earth is wrapped in a thick blanket of air called the atmosphere, which is made up of billions and billions of tiny gas particles that we can't see. These invisible particles are floating all around us, from the ground up to space, creating a protective bubble around our entire planet. The atmosphere is what lets us breathe and protects us from harmful space radiation. When sunlight enters this atmospheric bubble, something really interesting happens to all those different colored light waves we learned about. When sunlight hits all those tiny gas particles in our atmosphere, the light waves start bouncing around like ping-pong balls in a room full of obstacles. This bouncing process is called scattering, and it happens to all colors of light. However, remember how blue light has those short, energetic waves? Those short blue waves get scattered much more than the longer red waves because they bump into more particles. It's like throwing different-sized balls through a forest. The smaller balls, blue light, hit more trees and bounce around more than the bigger balls, red light. You might be wondering, if violet light has even shorter waves than blue light, why isn't the sky purple instead? Well, there are two cool reasons for this. First, the sun doesn't produce as much violet light as blue light, so there's less violet to scatter around. Second, our human eyes are much better at seeing blue light than violet light. It's like our eyes have a favorite color. Some of the violet light that does get scattered gets filtered out by our atmosphere before it reaches our eyes, leaving beautiful blue as the winner. Have you noticed that the sky isn't always blue? During sunrise and sunset, the sky often turns amazing shades of orange, pink, and red. This happens because sunlight has to travel through much more atmosphere to reach us when the sun is low on the horizon. During this long journey, most of the blue light gets scattered away in other directions before it can reach our eyes. Only the longer red and orange light waves are strong enough to make it through all that extra atmosphere, which is why sunsets look so warm and colorful. Here's a mind-blowing fact. If you were an astronaut floating in space, you'd see a completely black sky, even during the day. This is because space has no atmosphere with those tiny gas particles we need for light scattering. Without an atmosphere, sunlight just travels in straight lines without bouncing around, so there's no scattered blue light to fill the sky. The sun would look like a bright white dot against the darkness, and you'd be able to see stars even during the daytime. This proves that our blue sky is really a special gift from our planet's atmosphere. Follow-up question: what other everyday things around you do you think might involve light scattering? Drop your guesses in the comments below.